In the last video, we had seen interfacing of a 16x2 LCD with LPC1768, and we saw that we have used the LCD in the 4-bit mode. So by doing so, we have saved 4 I/O pins of LPC1768 microcontroller. Now in this video tutorial, we shall see the interfacing of 4x4 keypad. Now, the objective of arranging these 16 keys in the matrix form is also to save the input and output pins of a microcontroller. For example, 4x4 means totally we have 16 keys. So if we had not connected this in the matrix form, then we should have dedicated 16 GPIO pins to connect these 16 keys. Whereas when we have placed this in the matrix form, that is, these 16 keys are placed in such a way that there are 4 rows. So this is row number 0, row number 1, row number 2, and row number 3. Fine. So row number 0, it is P1.9. Row number 1 is P1.10. Row number 2 is port 1 and 14th pin. And row number 3 is the 15th pin of port 1. Then we have columns, right? So P1.0, this is column number 0. We start from 0. P1.1 is column number 1. P1.4, it is column number 2. P1.8 is column number 3. So with this arrangement, the advantage is very much evident. You can see totally we have used only 8 I/O pins, 4 to connect the rows and 4 to connect the columns. So with this arrangement, we have saved 8 I/O pins compared to the normal interfacing if we had done. That is the advantage of placing the keys in the matrix form. Of course, this will increase complexity in the software, but the advantage is more superior. Fine. Now, if you see these arrow marks, this indicates that these port pins which are connected to the rows, they have been configured as output port. And if you see these arrow marks, it indicates that P1.0, P1.1, P1.4 and P1.8, they have been configured as input pins. So rows have been configured as output pins, whereas the columns have been configured as input pins. So in such a situation, if there is no key press, so these columns will be always reading a logic 1, because when all the keys are open, they behave as an open circuit. So if you see as a case study, P1.0, this is connected via a 10K resistor to a high voltage of 3.3. Similarly, the other pins P1.1, P1.4 and P1.8, by default, when no key is pressed, will be always reading a high signal. Hence, whenever you press a key, that specific I/O pin will read a 0, which indicates that a key has been pressed, and then in the software we detect that key based on the row number and the column number. For example, let us assume we have pressed key number 0. So in such a case, what will be the row number? So this is row 0, row 1 and row 2. So in row 2, which is the column? This is column 0 and this is column 1, right? Hence, in row 2 and column 1, a key has been pressed, which is nothing but 0. So once we detect this, we will display this key onto the LCD. We shall see that in detail when we discuss the software part. But this is all about the interfacing of a 4x4 keypad with LPC1768.